Okay, so I'm back again, and today I have took this shit apart, did the calcination, the first layer on the other beads, which turned out to be like white, so we have to figure that out as well. But because I have the parts now and the snubber works well, I have tested it out with the automated calcination shit. I am going to put this back to order and heat the chamber up. Tomorrow I'm going to, basically I have been tinkering around with this. This is basically the current version of the flow system. This is a very makeshift thingy. This basically does one thing, or it is like a, a gearbox here. This is the like the needle valve body, and there is a needle valve in there, which I probably can't see because there is not much light here. I would like to change that, maybe like this, whatever. So there is like a threaded rod here that slides up and down, and there is like a needle like thingy at the end, which is like a conical thing, and can shut off the total flow, and with that I can basically control the inflow. Sorry, I can control the inflow, as I wanted to say, rather than this little binary or like tight thingy. I can digitally and fully automatically control the flow that goes into the burner chamber. Thus, I can how do you say this? Affect how much sulfur I'm burning, because the sulfur burning is constant at there if we are supplying air. If we decrease the air, then there will be less sulfur burned, thus there will be less sulfur dioxide in the air. That goes through here, and basically because one way, here is the bypass valve, or the Y connection. One way goes to the burner, the other one goes to the dryer, and basically the burner's one goes back, and there is like a one-way valve here, a check valve here, so that there is not going to be black flow when that is shut off. So as we control here the input air that goes to the system, with that I can increase or decrease the amount of SO2 burnt, or sulfur burnt and SO2 created. With that I can adjust the amount of sulfur dioxide concentration. So basically, because if there is a constant air on the bypass side, then this is reduced, then the total amount of concentration of SO2 will decrease as well. So then if we have, like, you get the point. And the remaining sulfur dioxide air combo goes to the catalyst and does the good old path. And basically tomorrow I'm going to test out. Here are the GUVAs, so the first catalyst chamber and the third catalyst chamber. Basically I can measure how much sulfur dioxide I'm making, and with the concentration unchanged, because there will be no heating tomorrow, I will just use and we'll set this up, and then we'll be able to, like, with the pot meter here, I can, this is unplugged now, but with, I don't know where it is here, this is the so yeah, this is the target value. Basically this is like, with this I can adjust this or yeah, with that I set like a target value from 0 to 1024, which in turn turns this motor till this this other pot hits that same exact value that I'm looking for. This is the target, this is the actual, and with that movement I adjust the needle valve position back and forward, so I can close off and so decrease as I basically threaded like in, decrease the amount of air going into the burner, and this will be used to the main to the bypass as well, so I can decrease the amount of air going through the whole system. And there is like a pressure sensor here that is a differential pressure sensor, which like measures how much pressure there is, like how much pressure drop there is between the two lines or through the needle valve, and I can basically like have some information about the system's behavior. Now it's not that working that well. I will have to fix it, but first I will assemble the system and I will do this so I can have like information and will be able to like see how much sulfur dioxide I'm having per unit of I don't know, flow in, but I will record the pot, like the value, basically as you turn it, it increases in value from 0 to 1024. If you use like a ESP32, then it's like 5096 or something like that. So, or 4000, I think 4096, sorry. So whatever, it's basically the same, but there is more resolution in that. So yeah, we'll record that and we'll have data so I can start like testing out the system and start doing the actual model that will be used to predict things like temperatures and have like a, it is called PID, which is like a proportional integral and derivative term control, but I will swap that because this system is probably pretty nonlinear. We'll talk about this later in the controlling parts of the series. Now I'm just building it, but these steps are necessary to be able to implement the automation of the system, which is like based on control. And like it sounds complicated, and it is probably it sounds more complicated than it is. It's just not like, it's like mathematical terms, but it is not that difficult to understand. If you get the grasp, then you can basically be able to like do it as well. So yeah, we'll do that and we'll work on this in the upcoming days and we'll test the system. Hopefully there will be minimal errors that I will have to fix, but yeah, we will have to wire this shit up as well tomorrow, because then the wires have to go there, which is quite a long distance from here. So yeah, that's it for today. Thanks for watching. Do the hard work, especially when you don't feel like it.